3 is about preparation of solutions and a hand sanitizer. Objectives of the experiment are to learn how to make solutions, determine the molarity of the solution, how to prepare an antibacterial solution, and how to make a hand sanitizer as an application of chemistry during this time of pandemic. So we're now by the balance, and by now you know how to weigh. This is the balance is zeroed, so it's 0 right now. So the salt is sodium chloride, NaCl. This is also referred to as the table salt. And then, so the process to weigh is I have the weighing boat. This is the weighing boat, and I'm gonna put it inside the balance. Okay, like that. And then I'm going to weigh the salt, but I will zero this again by pressing 0. So the weight of the boat is now zeroed, and I'm going to put 5.844 grams of the NaCl by using a spatula like this. So I now have a spatula or a scopula, and then I will put 5.844 grams of the salt. Okay, and I'm looking at the weight. Okay, so I need more, 5.844 grams. Okay, a little bit more. So I close it, and then we're gonna let it, so leave it for a few seconds or a few minutes until it doesn't fluctuate. So right now I have 5.845. So write this down, please. 5.845 grams is the weight of the NaCl. So this is now the salt that I weighed, 5.845 grams, and then I'm gonna put it now in the beaker. So we're preparing a solution, and I labeled that as part A NaCl, and this is now the water. So water is, I measured with a graduated cylinder, 100 ml. So exactly 100 ml, 100.0 ml, and then I'm just gonna pour it into the beaker. And then I'm gonna stir it using a stirring rod, glass stir rod, and then to dissolve. So it will dissolve fast. So a solution is when you put the solute and then the solvent. So in this case, the solute is your NaCl, that's the salt, and then the water is the solvent. So bigger quantity is the solvent, the solute is a solid, your water is a liquid. So there's going to be an interaction between the salt and the water, that's why it dissolves. So remember that water is polar, and then your NaCl is ionic, it's an ionic compound. There's going to be interaction between the two, so that it will, so if there's interaction, then that solute will dissolve. So in this case, NaCl. So the same thing actually at home. NaCl is your table salt. You put salt, in your food, or when you're cooking something, it will dissolve in the water. So now, a solution is that you don't see any separation of the layer. You don't see particles. So you don't see particles that's undissolved. Okay. So the solute is completely dissolved in water. So your NaCl dissolves completely in water. So it's clear, transparent. Okay? Alright. So that is part A. That's your solution in part A. So NaCl. So now what you're going to do is you're going to determine the concentration and then put the information or write down the information in the report form. So now weight of NaCl used, volume of water added, volume of water in liters. So you are going to convert the ml to liters. Again, taking into consideration the significant figure, and then write down the formula weight of NaCl, grams per mole, and then moles of NaCl, and then you determine the molarity to the correct unit and significant figure, so show calculation at the bottom. So that's going to be the report form. You're basically just filling in the blanks, but show the calculation, please. So that's part A. Part B, we are now weighing the same NaCl, but this time I'm only weighing 0.900 grams, so exactly 0.900 grams for part B. And you can see that I did the same thing, and then the weighing boat inside has 0.900 grams of NaCl, so the same salt. Okay, so I'm gonna dissolve this again in 100 ml of water. So this is now the salt that I weighed for part B, 0.90 grams of NaCl. And again, I'm gonna put it here in the beaker. And then I measured again 100 ml of water. So again, when you're reading this, when you read this, it's going to be again lower meniscus here. So 100.0 ml of water. So again, I'm gonna pour and then dissolve the salt in 100 ml of the water. So the same thing. Okay. So remember for part A, I weighed 5.845 grams, and then this one I only weighed 0.900 grams of NaCl. And then it should dissolve too, right? So this one has more weight, this one has less weight. Okay? And that means that this part A solution is more concentrated than the part B solution. So once it's dissolved, we're going to compare. So it should dissolve faster. The same thing, solution. When you make a solution, it should be transparent, clear. You don't see any separation of the solute and then the solvent. So again, the same thing, the solute here is NaCl, solvent is water. And you are now going to determine the concentration in terms of mass percent. Okay, so for part B. And then you are going to do also the calculation. In the final lab report for part B, which is mass percent of NaCl, you are going to write down the weight of NaCl used, and then the volume of water added, and then the density of water, which is 1.00 gram per ml. And then you are now going to determine the weight of water used based on the density and the volume. And then determine the mass percent of NaCl solution in the sample. And then answer the question, please, by showing how to prepare solution B from solution A. So now going back to the solution in here. So this is more concentrated, this is less concentrated. You don't see a difference. Here it's hard to determine which one is, there's no way to determine, okay? However, if I put more, at some point, this NaCl will not dissolve, meaning that you supersaturated, you will see the NaCl, some of the solid will not dissolve anymore because there's a maximum amount that the water can dissolve the NaCl based on the volume that I'm adding. So the solution right now is composed of NaCl plus H2O, NaCl plus H2O. Part C is preparation of an injectable IV. We are now going to weigh 2.5 grams of dextrose or glucose, and then we are going to dissolve that in 50 ml of the saline solution that we prepared in part B. And then mix the solution to dissolve. So in this case, you are actually, you have two solutes. That would be NaCl and then glucose, and then the solvent is still water. This is now the weight of the glucose in part C, and as you can see inside, I have the sample already in the weighing boat, and this is the glucose dextrose that I used. So I scooped the glucose, the same procedure, and then weighed 2.500 grams. So write that weight, please, 2.500 grams, exactly 2.500 grams. And then I'm gonna take it out. So this is now the dextrose that I weighed, and then I'm gonna put it again in a beaker. So I labeled this as part C IV. Right, so that's the dextrose, and then I took 50 ml of that part B solution. So it was 100 ml before, so you can see 100 ml. So I took out 50 ml. I measured 50 ml using the graduated cylinder, and again I'm going to dissolve it. So remember, this is NaCl, this is saline solution, and then however we're gonna mix one more solute, which is the glucose or dextrose. So the same thing, I'm gonna pour it, and then I'm gonna stir it again using a stirring rod, and it should dissolve. So glucose is a sugar. It's one kind of a sugar. You're gonna learn this later in the semester when we talk about biochemistry. It's different than sucrose. Sucrose is the table sugar. Salt, NaCl, is the table salt. Your sucrose and glucose are different. Okay, they're not the same. They're not the same structure. They're both sugars or carbohydrate, but structurally they are different. So you can see that it actually became clear. So you don't see, I still see some specks at the bottom, so I want to dissolve completely. So once you make the solution, the solute seems to disappear, right? So you don't see any layer again, it's homogeneous. You don't see separation of the layer. It's completely like water. So you will not be able to determine what's in the water because it's clear. Okay? So that is your IV, injectable IV. And it's clear solution. Alright? So that is basically your part C. Part C in the final lab report is you have the preparation of an injectable IV USP solution. You are going to write down the weight of dextrose that we used, and then the volume of saline solution used, and then determine the concentration of dextrose in the solution. We're now doing part 2, which is the dilution. So I'm going to illustrate how to dilute a solution. And we're just using the solution that we made in part A, which is the sodium chloride solution. So to illustrate, I will put, so I have 2 beakers in here, and then I'm gonna put a drop of the blue food coloring, 1 drop. So blue food coloring, 1 drop each beaker. So intensely blue, so basically just a drop. Okay, and then I'm going to split the part A NaCl solution into 250 ml cylinder. So I now have 50 ml each of the part A solution. So I split the solution that we had from part A, NaCl aqueous solution, into two 50 ml graduated cylinder. So now I'm just gonna pour it here. Okay, and then the other one the same. Okay, so the color intensity is the same. So I now have two beakers exactly the same. I just split the previous solution. However, for beaker number 2, I'm going to put additional 50 ml of just water. Okay, so we're going to compare the intensity. Okay, so this is the more concentrated one, and this is going to be the diluted one. So the one on the left is the concentrated one. So this one I added 50 ml more of the water, and you can see that the intensity of the blue coloration is in fact much more in here than the one on the right. So this is the diluted one, and this is the more concentrated one. So now you are going to determine the concentration of the diluted one. Okay, so obviously the concentration here will be less than the one on the left side. Part 3 is about preparation of a hand sanitizer. The first part is preparation of basic antibacterial solution, and then part B, we're going to add aloe vera moisturizer. So part A, I'm just going to mix absolute ethanol. So this is absolute ethanol. And then I already measured 35 ml. So 35 ml, 35.0 ml of the absolute ethanol into the graduated cylinder. And then I'm just going to mix 15 ml of water. So this is just RO water. So 15 ml of the RO water. So I'm just going to mix it here. So basically I'm voluming it to, I'm just adding up to 50 ml, and I will add using the squirt bottle. Okay, so I'm mixing the two together. It's soluble. Okay, so this is now your basic hand sanitizer that you can use. You can already use this as an antibacterial solution or antiviral solution, or as a disinfectant, or as a sanitizer. So I can, ethanol and water actually, they mix in all proportions. Okay, when you mix it, it's a little bit warm because there's a heat of solution that is formed when you're mixing two solvents together, and you see that it's again a solution. I can mix it. Okay, and then you don't see again any layer. It's not like your salad dressing kind of mixture of oil and vinegar that you see when you're putting it in your salad. Okay, so that is the antibacterial solution. Okay, the next part is now you are going to determine the concentration of the solution expressed as percent by volume of ethanol. So you're gonna fill up the spaces, okay, the blank spaces. So again, it's gonna be, so you're gonna fill this up, okay, volume of absolute ethanol, and then volume of water added, and then now what is the concentration of ethanol in the solution, okay, percent by volume, okay, to the correct unit and significant figure. Again, apply the concept of sig figs that we learned previously. So now we are doing now part B. I'm gonna add, we're gonna mix aloe vera gel. So typically when you buy something in the store, they put aloe vera as a moisturizer, And then we're just gonna use the antibacterial solution that we made. So there's a minimum amount of ethanol that you should have in your solution, otherwise it will not be an effective disinfectant. Okay, so determine the concentration that we prepared from part A, and here we're just adding aloe vera. Okay, so the procedure is in the handout. We are measuring 7 ml of an aloe vera gel, and then you're going to add it to 43 ml of ethanol solution that we made from part A. So part A, we prepared 50 ml, right? So we are taking 43 ml of that solution and then combining it with 7 ml of aloe vera gel to have a total volume of 50 ml. Okay, so now, so I'd set this aside, and then we are going to measure 43 ml of this solution. Okay, we can use this again, actually. Okay, and then I have here an aloe vera gel. So I bought it. So this is the aloe vera gel, 100% gel. And if you read the label, actually at the back, and they said that it's 100% pure aloe vera gel. It's fragrance free, no color added. Although if you read the fine print here, they actually added more stuff. Okay, so it's not entirely just aloe vera gel. There's like tocopherol acetate, triethanolamine, and then EDTA. So they have more chemicals that actually they added. But although they claim that they did not test these, they did not do any animal testing. So you can see the fine print in here, okay? And then, as I mentioned, you have tocopherol acetate and triethanolamine. It typically functions, some of these is functioning as a preservative. If you are using the natural aloe vera, it still has active enzymes and it would tend to precipitate out. So however, for this one, it's not entirely clear, all right? There's a little bit of turbidity, and I will show you later. We have a hand sanitizer here in the lab, but let's prepare this one. So again, this is the aloe vera gel, and then because it's a gel, it was difficult to measure. So I have here a cylinder, and then I measured about 7 ml. So it's actually sticking to the side. Okay, so approximately 7 ml of the gel. Okay, so coming from here, so I basically just pour it like that. And then we're gonna take 43 ml of these of this solution and then mix it together. That's gonna be our hand sanitizer. I measured 43.0 ml of the ethanol solution that we made from part A. The remainder, 7 ml, is still here. Okay, so now I'm going to mix this together, this 43 ml and then 7 ml of the aloe vera gel. So I simply put this here so that I can take out the gel, and then I will try to dissolve it. Okay, it takes a while to dissolve, but it will dissolve. Okay, so it's getting less viscous the more I stir it, and then I'm gonna pour it here so that I can take out as much as possible that gel. And because this is actually a smaller container, this is now the hand sanitizer. So as you can see, it's a little bit turbid. There's some turbidity to it. So I put everything, the aloe vera gel that I measured 7 ml, and then the 43 ml of the solution that we made in part A. So this is the remainder. So I can actually use that too because that's an antibacterial solution, ethanol solution in water. And I have here a hand sanitizer in the lab, so you can see that actually has some turbidity, and they said that it's with moisturizers and vitamin E. Okay, so this is the hand sanitizer. All right. They said that the ethyl alcohol antibacterial is 62% in this clear and natural products, right? So this is the commercially available hand sanitizer, and it's not far, right? So we made a hand sanitizer with the aloe vera gel in here, and you can do this at home. So you know, at home, if you are trying to do this, you can buy this, and you can buy ethanol. However, because you probably don't have any graduated cylinder, you can just measure this, you know, with your laundry, you know, measuring cup. And then as long as the amount of ethanol that you're putting in is still within the minimum amount, which is 60%. So don't go below that. You can always go higher in terms of the amount of ethanol, but don't go below 60% because it will not be effective as a disinfectant. Okay, so now you can say, for example, so I want to keep it, right? So I can label this little container hand sanitizer with aloe vera, and I'm gonna pour it here. So there's still a little bit of a gel actually that's at the bottom, but I'm gonna shake it. Okay, all right, so now so that is my hand sanitizer. You can try our product, so I can try it here. Okay, so okay, not too bad. All right, last part is now part B, addition of aloe vera moisturizer. So you're gonna write in the blank volume of aloe vera gel in ml, and then volume of ethanol solution added, and then concentration of ethanol solution used, and then the last one is the concentration of ethanol with aloe vera, the final concentration after we added the aloe vera gel to the correct unit and significant figure. This is the aloe vera plant that I'm going to show you how to cut. You can buy this in the store. It's about maybe $2. And as you can see, there are like, you know, spikes on this, so you have to be careful. And I'm actually wearing gloves. And you can wash these before you cut. Here, but of course you can also, you know, include this, but you can cut this one because really does not have anything. And now I'm going to cut this part, and then I'm going to cut like this, like that. And then you can cut the spikes. It's sharp, so you have to be careful. And you can do the same thing for this piece. You can cut here, you can also cut here, and then to clean up the spike. And now this is the gel. It's very slippery, and then you can take out the outer layer. This is very hard, so you can take out that layer, and again the other side, take out, and it's very easy to remove it. It's soft, but this green stuff is hard. So I got the gel. So this is like clear, transparent. And if you want to eat it, you can slice it again, and then, or this actually doesn't have any taste. It has kind of like maybe very slight bitter taste. Then, or you can put honey if you want. But I ate it as it is, and it's very slippery. And you can blend it, you can put in the blender, and then that's gonna be your gel. So again, this is your aloe vera gel.